So when we're looking at this first problem, we're going from from grams, we're in grams, and we want to go to moles. Okay? You're going to need to use the periodic table for this, because the only place that we know what water weighs is from our masses from our periodic table. Right? So, if you forget, water is H2O. Okay? So to find our mass, we have 2 hydrogens and 1 oxygen in water, yes? Everyone gets that part? Okay, so look on the periodic table. How much does hydrogen weigh? 1. And we have 2 of them. So hydrogen weighs 1 times our 2 of them, which equals 2. How much does oxygen weigh from the periodic table? 16. And we only have 1 of them. So we add those up. 2 plus 16 is what? 18. So our total mass of 1 water is 18 grams. Following me? Where the heck did those numbers come from? Good? Thumbs up? Okay. All right, so that's our gram of 1 water molecule. We have 15 grams. Okay, so we need to figure out how many of those ones do we have in our 15? And you would think, oh, 15, but no, that's not how it works. If only that was how it works. So what we do is we go to moles from our masses. Okay, remember how yesterday we talked about a mole is 1 set of whatever you're doing. So in this case, 1 water. So when we do this, we have to start with what was given in the problem, which is 15 grams. Okay, and then we're going to draw a little T-chart. Oops. Like this. My pencil keeps breaking. This is called a conversion T-chart. And all it does is it's just a really good way to keep track of your numbers. Okay? If you remember back from fractions, whatever you put on top of a fraction can be canceled with what goes on the bottom, right? So like, say you had, just over to the side, an algebra problem that was 2x times y over 2x. We learned in algebra, maybe if you remember, that we can take this 2x and this 2x and cancel them out, which is just y. Remember that? Well, we do the same thing in our chemistry problems with our units. So if we have grams on top on this side, we're going to want grams to go on the bottom next so that we can get rid of it. Just like a fraction. And in this problem, we got our grams from the periodic table. What was our mass we found from the periodic table? 18. We're just going to put it down here. And now that we have grams on top and grams on bottom, we can get rid of them. And we're on to our next section of our T-chart. Super fun so far. So those masses that we got from the periodic table, they equate to something. Those masses on the periodic table always equal 1 mole. So if we're making a fraction, we got to make a top and a bottom. So this 18 grams is the same as 1 mole. Because that's what the periodic table tells us. That is the weight of 1 of water. Okay? I know it's new, but are we following where the numbers are coming from? Okay. All right. So now we have moles on top. We want to be in moles. So we don't want to get rid of our moles. That tells us that we're done. Now that we're in moles, we're done with our T-chart. Okay? Now we just have to solve the T-chart. When you're solving a T-chart, you multiply across the top, multiply all the way across the bottom. I'm just writing this for our peeps at home. And then divide the two. Which you can jot that down if you want. I'm just writing it down for my peeps at home. But what that means is we're going to do 15 times 1. What does 15 times 1 equal? 15. I have to move over here. Sorry. 15 on top. And then it's in moles. That's what's left. So we got 15 moles on top. 18 times nothing. So just 18 on the bottom. And this, if you don't remember, a fraction is just a fancy division problem. So we're going to take our calculator. And we're going to do 15 divided by 18 equals a teeny tiny number. 83 moles. That's our answer. No. Sorry. So the question said how many moles are in 15 grams of water? 0.83. Now to check ourselves, let's use our logic. If 1 mole of water weighs 18 grams and we only have 15, we knew we were going to be less than 1, right? But pretty close. 0.83 is pretty close to 1, so it makes sense. I'm going to stop this. That's probably